Today's lesson is going to be on identifying functions from tables and graphs. So if you open up your packet to page 12, we'll get started. On page 12, there's notes on how to determine whether or not something is linear, quadratic, or exponential. In order to do that, you're going to be looking at the pattern of the y values. So in order to test if a function is linear, you're going to be looking again at the y values and finding the difference between the y's. Now, difference means that you want to take and subtract the y values. And in order to be linear, the first differences, meaning you subtract one time, the first differences must be the same. Now, we have talked about lines before and even identifying them on tables. In order to be linear, it must be increasing or decreasing at a constant rate. So if you're looking at this table, when you look at the y's, from 5 to 7, it's increasing by 2. 7 to 9 is increasing by 2. You do also need to pay attention to the x's, that those are also increasing at the same rate. Now, 5, 7, 9, you're going to see that those numbers are going upward. That's how you can tell that it's increasing, which is why it would be a positive 2. Now, these numbers are easy enough to just figure out in your head, but once the numbers get larger, what you want to do is take and subtract the numbers. You're going to start with the second one and subtract the first one. So you would be doing 7 minus 5, you get positive 2. Then I would take and I would do the 11 minus 9, and you would end up with 2 again. So remember, when you're doing the subtraction, you're going to be starting with the numbers underneath it first and doing 7 minus the 5, 9 minus the 7. And since this is increasing at a constant rate, that's how you can tell that this is going to be linear. And again, that is called first differences. Looking at the next one, it's how you determine whether or not something is a quadratic. To do that, you have to take and find the differences between the first differences. So what that means is you're looking at the second differences. If the second differences are the same, that means that the function will be a quadratic. Now, second differences means that you need to take and you should be subtracting twice. If you subtract the y value twice and you get the same number, that's how you know that it would be quadratic. Now be careful with the negatives when you're typing them into your calculator. So again, you would want to start with the negative 448 and you're subtracting negative 567. Use your calculator and be careful here with the double negatives. So you would type in your calculator negative 448, then you're going to hit the subtraction sign, then negative 567. That's going to give you a positive 119. Then you would want to take and do negative 343 minus a negative 448, and you would get a positive 105. That's what you're doing to get these numbers, which are called the first differences. Now, when you do that, you're going to notice that none of those numbers are the same, and that is why it is not linear. So now you have to take and do your second differences. So to do the second differences, you'll be subtracting these numbers. So 105 minus 119, I get negative 14. 91 minus 105, I get negative 14, and you should be checking the entire table just to make sure that it's correct. Since everything for second differences is the same, that's how you know that it would be a quadratic. So again, second differences mean to take and subtract twice. The last thing you would need to know is how to figure out by a table whether or not if something is exponential. In order to be exponential, you have to take and find the ratios between the y values. If the ratios are all equal, it means that they have a common ratio. So again, a lot of times you can just look at the table and figure out what's going on, meaning to go from negative 10 to negative 20, you're multiplying by 2. To go from negative 20 to negative 40, you're multiplying by 2. If you're multiplying by the same number in the entire table, that would make this an exponential because it has a common ratio. Now, this one was easy enough to see that you're multiplying by 2, but to figure out what the ratio is, you would be dividing. The second y divided by the first y, you would get 2. You would do the third y value, which is negative 40, divided by negative 20. You would get 2. Negative 80 divided by negative 40, you would get 2. And yes, you should continue to check the entire table to make sure that it's the same for the entire thing. Now going on to the next page, they want you to take and describe what type of function and explain it. The first type you always want to check for is linear. So for linear, you're going to be doing 55 minus 48, and you end up with 7. Then I'm going to do 69 minus 55, and I get 14. Then I would do 90 minus 69, and I get 21. And when I subtract the last two, I get 28. Now this is not linear because it's not the same number and first differences are not the same. So now you would take and subtract the numbers again. I would do 14 minus 7 is 7. 21 minus 14 is 7. 28 minus 21 is 7. Now again, some of these questions you can do in your head, but since this is the same, which would be second differences, that's why this would be quadratic. And your explanation would be second differences are the same. Are the same. Going on to the next one, again, you're always going to be checking for linear first. So again, to do this, I'll be typing in my calculator, negative 20.3 minus negative 24.3, be careful with the double negative, and I get 4. Then I would do negative 16.3 minus a negative 20.3, and I get 4. You would keep subtracting, and in this case, they do all end up being 4. Therefore, this would be linear, and your explanation would be first differences are the same. For question number 3, now these numbers are decreasing, meaning you should have negative numbers when you're subtracting it. And again, sometimes the numbers are small enough that you can realize to 22 to 17 you subtracted 5, 17 to 12 you subtracted 5, and you subtracted 5. If you can't figure that out, then again, you're doing the second number minus the first number is negative 5. The third number minus the second number is negative 5, and you would continue from there. But this one, again, would be linear, and your explanation would be first differences are the same, or you can be using the word constant. On the next one, first I'm going to take and subtract, or again, the numbers are small enough to go from 2 to 4, you add 2. To go from 4 to 8, you add 4. Then I add 8. Now, right away, some of you might realize that there's a pattern here. So for this, you can check for your quadratics next by subtracting, but clearly those are not the same number. So if first difference doesn't work and second difference doesn't work, then it's going to have to be an exponential. To go from 2 to 4, you multiply by 2. 4 to 8, you multiply by 2. If you're multiplying by the same number, that means it's going to have to be an exponential because it has a common ratio. Now, if you were unable to determine that you were being multiplied by 2, for exponentials, you would be dividing the second number divided by the first number, the third number divided by the second number, and when you're dividing, if you get the same number, then that means that it would be exponential because it has a common ratio. Pause the video now and do questions 5 through 10 on pages 13 and 14. So number 5 you should see is an exponential because to go from one y value to the next, you would be multiplying by 2, so it's exponential because there is a common ratio. Again, to check that, 10 divided by 5 would be 2, 20 divided by 20 divided by 10 would be 2. For number 9, all of these are increasing by 9, therefore it's linear because first differences are the same. Question number 7 is also linear because first differences are the same, and each y value is increasing by 2. For question number 8 would be exponential because there's a common ratio. To go from one y value to the next, you're multiplying by 3. Again, if you need to, you would be dividing to figure out what your common ratio was. The second one divided by the first one, the third one divided by the second one. Number 9 would be a quadratic because when you subtract once, none of these y values or the differences would be the same. But once you take and you subtract it again, you would end up with tens. So therefore, second differences are the same, making it a quadratic. And question number 10 is also an exponential because each of those you have to multiply by 2 to get to your next y value. Question number 11 is the same thing, it's just multiple choice. They want to know which one is linear, meaning which one has a constant rate or which one has the first differences the same. So if I look at example 1, I'm increasing by 7, by 7, and 7. So your answer does end up being choice 1, but you should still always go through all of them and check to see if you're increasing by the same number, and the other tables you were not. Now, as far as determining from a word problem, question number 12 is asking which one is an exponential. Exponential means that it has to deal with some type of common ratio. Now, if you're looking at this, anytime you see the word doubling, that's a key that it's going to be an exponential. In choice 3, you're going to see that you're increasing by a percentage. That also would mean that decreasing by a percentage would have to be an exponential. But for number 2 here, if it's growing 1 inch every 4 days, that would be linear. The reason is it's going to be constant. No matter what, every 4 days it grows 1 inch. So the ones that have to be exponential would only be 1 and 3. Going on to the next one, which one is not linear, meaning not constant, choice 1 says that it's going to go down $10, the fee is $10 and it goes down $10 per month. That number never changes, therefore it's going to be linear because that's a constant. Number 2, it's going to be $3 per mile. That never changes, therefore it's constant. Number 3, again, $12.50 per hour never changes, it's going to be constant. Therefore, choice 4 is saying that it's depreciating 15%. So therefore, that is not a constant rate because once you take 15% and you subtract it, then you're taking 15% of a smaller number. Therefore, it has to be choice 4. Number 14 and 15, try those now on your own. So number 14, the exponential would be choice 3. It's exponential because it has the word doubles in it. And for